September 27th, 1942, Hamburg, Germany. Oberingenieur Friedrich Hartmann sat in the offices of Blohm and Voss Shipyard, one of Germany's premier naval construction facilities, studying intelligence reports that had arrived from the Abwehr that morning. The documents detailed American shipbuilding claims that seemed so absurd, so physically impossible, that Hartmann assumed they were deliberate Allied disinformation designed to damage German morale. They claimed to have launched a 10,000-ton cargo vessel in 4 days, he announced to his assembled staff of senior engineers and naval architects. 4 days from keel laying to launch. This is what the Americans want us to believe about their shipyards. Around the conference table, Germany's finest maritime engineers responded with appropriate skepticism. Gerhard Müller, chief naval architect with 30 years' experience, laughed outright. 4 days? It takes us 4 days simply to position and weld the keel sections. The Americans must think we're idiots to believe such obvious propaganda. Hartmann nodded, flipping through more pages of the intelligence report. They call them Liberty ships. According to these documents, the Americans claim they can build a complete ocean-going cargo vessel, over 400 feet long, in less than 2 weeks on average. They claim to have over a dozen shipyards, each building multiple vessels simultaneously. They project production of over 2,000 ships within 3 years. The room erupted in derisive laughter. Klaus Bergmann, director of production planning, shook his head in disbelief. 2,000 ships in 3 years. That's nearly 2 ships per day, every single day, for 3 consecutive years. The entire German shipbuilding industry produces perhaps 80 vessels annually when operating at absolute maximum capacity. The Americans expect us to believe they can build 25 times that number. Hartmann closed the folder and tossed it dismissively onto the table. Obviously fabricated, the Americans are attempting psychological warfare, trying to convince us that their industrial capacity is so overwhelming that resistance is futile. In reality, these Liberty ships are probably just standard merchant vessels that they're counting multiple times in different reports to inflate the numbers. Or perhaps they're classifying fishing boats and small coastal freighters as ocean-going cargo ships. Either way, this is propaganda, not industrial reality. What Friedrich Hartmann and his fellow engineers didn't know, what German naval intelligence had catastrophically failed to comprehend, was that every single number in those reports was accurate. Within the next 3 years, American shipyards would indeed produce 2,710 Liberty ships, using revolutionary construction techniques that reduced build time to an average of 42 days per vessel, with the fastest ship, the SS Robert E. Peary, completed in 4 days and 15 hours from keel laying to launch. These ships would carry 75% of all cargo supporting Allied forces, would replace submarine losses faster than U-boats could sink them, and would fundamentally prove that American industrial capacity operated at a scale German engineers literally couldn't imagine. The laughter in that Hamburg conference room would haunt German strategic planning for the remainder of the war. Because when your enemy can build ships faster than you can sink them, when production outpaces destruction by factors of 10 or 20 to 1, warfare stops being about tactics and becomes pure mathematics. And in that mathematical equation, Germany had already lost before the first Liberty ship ever touched water. To understand why American Liberty ship production shocked German observers so profoundly, we must first examine the state of maritime construction in 1942 and the conventional wisdom that made rapid mass production seem impossible. Traditional shipbuilding in the early 20th century was essentially a craft industry. Each vessel was built individually, with skilled workers cutting and shaping steel plates to fit specific locations on that particular ship. Hulls were constructed from the keel upward, with each section needing to be completed before the next section could begin. Riveting was done by hand, with teams of workers heating rivets, placing them in pre-drilled holes and hammering them into place while the metal was still hot. Quality control was maintained through experienced foremen inspecting work at each stage. This process was slow, labor-intensive, and required extensive skilled workforce. A typical merchant ship in 1940 took 200 to 250 days to build from keel laying to delivery. Larger vessels might require a year or more. Skilled shipyard workers underwent apprenticeships lasting several years to master the various trades involved in ship construction. The idea of dramatically accelerating this process seemed to violate basic principles of engineering and craftsmanship. German shipbuilding exemplified this traditional approach. Blohm and Voss, Deutsche Werft, and other major yards employed thousands of highly skilled workers who took pride in their craftsmanship. German engineers considered shipbuilding an art form as much as an industrial process. Each vessel was treated as a custom construction requiring careful attention to detail and rigorous quality standards. The idea of mass-producing ships like automobiles seemed absurd, a fundamental misunderstanding of maritime engineering complexity. British shipbuilding operated similarly, though with slightly more emphasis on standardization due to wartime necessity. British yards had increased production significantly since 1939, but still faced the constraint that building ships required skilled labour, specialised facilities, and substantial time. Britain's shipbuilding capacity was essentially fixed, limited by the number of experienced workers and available slipways. American shipbuilding in 1940 was actually quite limited. The United States had allowed its merchant marine to decline during the interwar period. Most American shipyards were small, building vessels on contract for specific customers, using traditional construction methods. Total American shipbuilding capacity in 1940 was approximately 1 million tons per year, less than half of Britain's capacity and roughly equivalent to Germany's. Then the emergency shipbuilding program transformed everything. In 1940, with Britain fighting alone against Nazi Germany and merchant shipping losses mounting due to U-boat attacks, President Roosevelt approved the emergency shipbuilding program with the goal of replacing Allied shipping losses and building sufficient cargo capacity to support Britain with American industrial production. The program's architects, led by Admiral Emery Land and industrialist Henry Kaiser, recognized that traditional shipbuilding methods couldn't produce vessels at the required rate. Their solution was revolutionary. Treat shipbuilding like automobile production. Develop a standardized design that could be mass-produced. Use prefabrication to build ship sections in factories away from the slipway. Employ welding instead of riveting to eliminate skilled labor bottlenecks. Divide construction into modular sections that different work crews could build simultaneously. And most radically, hire and train workers who had no previous shipbuilding experience, bringing in farmers, housewives, factory workers, anyone willing to learn specific standardized tasks. The Liberty ship design itself was deliberately simplified. Based on a British tramp steamer design, the Liberty ship was essentially a floating cargo box. It displaced 14,245 tons, measured 441 feet long, and could carry 10,800 tons of cargo. The design eliminated every unnecessary feature, every complexity that didn't directly contribute to the ship's primary mission of transporting goods across oceans. No elegant lines, no aesthetic considerations, just functional efficiency. The hull was constructed in sections, large modules built separately and then brought to the slipway for final assembly. A typical Liberty ship consisted of 250,000 separate parts, but these parts were organized into prefabricated sections that could be built by semi-skilled workers following standardized procedures. Engines, boilers, deck housing, and other components were manufactured in separate facilities and then transported to shipyards for installation. Welding replaced riveting as the primary method of joining steel plates. This single change eliminated the need for skilled riveters, one of shipbuilding's major labor bottlenecks. Welding could be taught to workers in weeks, versus the years required to train expert riveters. Welding was also faster, stronger, and eliminated the weight of tens of thousands of rivets. The entire hull was welded, not riveted, representing a fundamental break from traditional construction. The assembly process was revolutionized through prefabrication and modular construction. Rather than building the ship from keel to deck in sequential order, Liberty ships were constructed in major sections simultaneously. The bottom of the ship, the sides, the deck, the bow, the stern, all built as separate modules by different work crews. These modules would then be lifted by cranes and assembled on the slipway like giant building blocks. This modular approach meant that hundreds of workers could work on different sections of the same ship simultaneously, rather than waiting for previous sections to be completed. Work that traditionally happened sequentially now happened in parallel. The keel section could be under construction, while the bow section was being fabricated, while the engine room was being assembled, while the deck housing was being built. When final assembly began, these completed sections came together in days rather than months. Kaiser's shipyards pioneered the moving assembly line concept for ships. Rather than building vessels on fixed slipways with workers moving to the ship, Kaiser designed shipyards where workstations were organized sequentially and ship sections moved through these stations as construction progressed. This mirrored automobile assembly line concepts, bringing industrial mass production techniques to shipbuilding for the first time. The workforce transformation was equally revolutionary. Traditional shipyards employed workers who had spent years learning their trades. Kaiser's yards hired anyone willing to work and provided intensive on-the-job training focused on specific, standardized tasks. A worker didn't need to understand ship construction comprehensively. They needed to know how to weld one type of seam, or install one type of fitting, or operate one specific machine. This division of labor meant that unskilled workers could achieve productivity comparable to skilled craftsmen within weeks rather than years. Women entered shipyards in unprecedented numbers. Rosie the Riveter became a cultural icon, though Liberty ship workers were actually welders rather than riveters. By 1943, women comprised approximately 30% of the workforce in many Liberty shipyards. They performed every job men did, from welding to crane operation to quality inspection. This doubled the available labor pool and shattered traditional assumptions about who could build ships. The results were staggering. The first Liberty ship, SS Patrick Henry, launched September 27, 1941, after 244 days of construction, a respectable time by traditional standards. But as the production system matured and workers gained experience, construction times plummeted. By mid-1942, Kaiser's Richmond Shipyard No. 2 was completing Liberty ships in an average of 42 days. Some ships took less than 30 days. The SS Robert E. Peary, launched November 12, 1942, was completed in 4 days and 15 hours as a publicity demonstration, though this required round-the-clock shifts and represented an unsustainable pace. Even more remarkable than individual ship speed was aggregate production. By 1943, American shipyards were launching an average of 3 Liberty ships per day, 3 complete 10,000-ton cargo vessels, every single day. 18 shipyards operated simultaneously, with multiple slipways per yard, creating a production conveyor belt that churned out vessels faster than German intelligence officers could believe. When these production statistics reached German naval headquarters in late 1942 and early 1943, the initial reaction was identical to Friedrich Hartmann's dismissal: propaganda, exaggeration, impossible claims designed to intimidate. German U-boat commanders were assured that Allied shipbuilding couldn't possibly keep pace with submarine sinking rates. If U-boats maintained pressure, the mathematics of attrition would eventually strangle Britain regardless of American industrial production. This assessment was catastrophically wrong. Kapitan Zur C. Karl Dönitz, commander of the U-boat force, calculated in early 1943 that U-boats needed to sink approximately 700,000 tons of Allied shipping per month to achieve strategic victory. This would exceed Allied shipbuilding capacity and force Britain to capitulate due to lack of supplies. In March 1943, U-boats achieved this target, sinking 627,000 tons while losing only 15 submarines. By this metric, Germany appeared to be winning the Battle of the Atlantic, but Dönitz's calculations were based on pre-Liberty ship British shipbuilding capacity. He didn't account for American production because German intelligence insisted American claims were propaganda. The actual Allied shipbuilding total in March 1943 was 1.3 million tons, nearly double the German target. The U-boats weren't sinking ships faster than they could be replaced. They were falling further behind every month as American production accelerated. The mathematics were brutal. In 1942, U-boats sank 1,664 Allied merchant ships, totaling 7.8 million tons. In the same year, Allied shipyards built 8.3 million tons of new shipping, with Liberty ships comprising approximately 5.5 million tons of that total. The submarine campaign was losing the production race. For every ship sunk, more than one replacement entered service. This trend accelerated in 1943. U-boats sank 3.2 million tons. Allied yards produced 13.9 million tons, with Liberty ships accounting for 9.1 million tons. The ratio had become unsustainable. Germany was losing the war not on battlefields but in shipyards. American workers welding steel in Portland, Maine, were defeating U-boat aces, hunting in the Atlantic more effectively than any destroyer or aircraft could. The psychological impact on German strategic planning was profound. When intelligence officers finally acknowledged that American Liberty ship claims were accurate, that the United States was indeed building cargo vessels at rates previously considered impossible, it forced a fundamental reassessment of the war's strategic balance. Gross Admiral Karl Dönitz submitted a report to Hitler in August 1943, stating, "We are now sinking approximately 100 ships per month. The Americans are building 140 ships per month. We cannot win a mathematical competition where the enemy produces faster than we can destroy. Unless we develop weapons or tactics that dramatically increase our sinking rate, or unless we can somehow attack American shipyards directly, the submarine campaign cannot achieve strategic victory." This admission represented the death knell of Germany's Atlantic strategy. If U-boats couldn't sink ships faster than America could build them, then the submarine force was fighting a futile campaign. Every U-boat sunk, every experienced crew lost, achieved nothing permanent because American production simply replaced the losses. The Liberty ship's impact extended beyond simple tonnage numbers. These vessels were specifically designed to be damage-resistant and easy to repair. The welded construction, while initially controversial, actually proved more durable than riveted hulls. When a Liberty ship was torpedoed, the damage was often localized. Many Liberty ships survived torpedo hits that would have sunk traditional vessels. Some ships were hit multiple times and still reached port. The SS Nathaniel Greene survived 3 separate torpedo attacks during a single convoy run in November 1943. After the third hit, the ship was dead in the water with massive damage. The crew abandoned ship, assuming it would sink. But the Liberty ship's compartmentalized design kept it afloat. A salvage tug towed the Greene to Iceland for temporary repairs, then back to Britain for full reconstruction. The ship was back in service within 4 months of being declared a total loss. This durability meant that gross tonnage sunk significantly overstated actual Allied shipping capacity losses. Many sunk Liberty ships were actually salvaged and repaired. The effective loss rate was lower than German reports indicated. Combined with new construction vastly exceeding losses, Allied shipping capacity wasn't just maintaining, it was growing rapidly despite the U-boat campaign. The versatility of the Liberty ship design also proved crucial. While designed as cargo vessels, Liberty ships were modified for numerous specialized roles. Some became tankers, others troop transports, still others repair ships, hospital ships, aircraft transports, or even floating barracks. The standardized design meant modifications could be implemented quickly and replicated across hundreds of vessels. This adaptability multiplied the strategic value beyond simple cargo capacity. American industrial planners also designed the Liberty ship program for sustainability. Unlike military production that might surge temporarily then decline, the Liberty shipyards were meant to operate continuously at high production rates for years if necessary. Workforce training programs, supply chain management, and production scheduling all assumed long-term operation. This meant American shipbuilding capacity wouldn't suddenly collapse due to labor shortages or material constraints. The system was built to maintain production indefinitely. German observers, who finally acknowledged Liberty ship production accuracy, struggled to understand how such rapid construction was possible. The concept of modular prefabrication, assembly line techniques applied to shipbuilding, and semi-skilled workers performing standardized tasks contradicted everything German engineering tradition held true about maritime construction. Oberingenieur Friedrich Hartmann, the same engineer who had dismissed Liberty ship reports as propaganda in September 1942, visited neutral Sweden in February 1944 on a technical exchange program. While there, he encountered detailed documentation from Swedish maritime observers who had visited American shipyards. The reports confirmed everything Hartmann had dismissed as impossible. Hartmann's diary entry from February 18, 1944, captures his shock. I have spent the day reviewing documentation of American Liberty ship production. The evidence is overwhelming and undeniable. They are indeed building 10,000-ton cargo vessels in 40 to 50 days on average. They employ production techniques that no German yard would consider acceptable, yet the vessels meet basic structural standards and perform adequately in service. The fundamental difference is philosophical. We build ships as unique constructions requiring skilled craftsmanship. The Americans build ships as industrial products requiring standardized processes. We strive for quality. They accept adequacy. We employ master craftsmen. They train factory workers. We construct vessels individually. They mass produce them. And their approach is defeating ours completely, because adequate quality produced in overwhelming quantity will always defeat superior quality produced in limited quantity when the war's duration exceeds the aggressor's resource capacity. We have superior engineering. They have sufficient engineering coupled with unlimited production capacity. And in modern warfare, sufficiency at scale defeats perfection at small scale. Most disturbing is the sustainability. The Liberty ship program is not a desperate surge that will exhaust itself. It is an industrial system designed for continuous long-term operation. The Americans have created shipbuilding capacity that can be maintained indefinitely, limited only by raw materials and labor force size, both of which they possess in vast abundance. We cannot match this production through any improvement in efficiency or any increase in worker hours. The scale difference is simply too large. I return to Germany with the certain knowledge that we are not fighting the American Navy. We are fighting American industrial capacity, operating at levels we cannot comprehend. And that is a war we cannot win through engineering excellence or tactical brilliance. That is a war we lose through mathematical inevitability. Hartmann submitted this assessment to Admiral Dönitz upon returning to Germany. The report was classified and distribution restricted because its conclusions were considered defeatist. But Hartmann's analysis was absolutely correct. Germany had lost the production war before most German officers even realized such a war existed. The human stories behind Liberty ship production reveal the social transformation that enabled this industrial miracle. These weren't career shipbuilders. They were ordinary Americans who became shipbuilders because the country needed ships. Eliza Grant, a housewife from Oregon, began working at Kaiser's Portland Shipyard in October 1942 after her husband enlisted in the Army. She had no industrial experience whatsoever. After 2 weeks of training, she was assigned to a welding crew. Within 3 months, she was a crew leader supervising 12 other welders. By war's end, she had worked on 23 Liberty ships and trained over 100 new workers. In a 1985 interview, Grant recalled, "I didn't know anything about ships when I started. I'd never held a welding torch before in my life. But they broke everything down into simple steps that anyone could learn. My job was welding specific seams in hull sections. I learned to do that one task perfectly, and I did it 8 hours a day, 6 days a week. Was I a shipbuilder? No. I was a welder who happened to work on ships. But when thousands of us, welders and fitters and crane operators, all did our specific tasks well, ships got built. That's how it worked. We weren't craftsmen. We were factory workers. And we built 2,710 ships because the system didn't require us to be craftsmen. It just required us to follow the process. This democratization of shipbuilding represented a fundamental philosophical difference between American and German industrial approaches. German industry relied on skilled workers with years of training. American industry developed systems that made skills less relevant through standardization and division of labor. The German approach produced superior individual craftsmen. The American approach produced greater aggregate output through process efficiency. The Liberty Ship program also demonstrated American resource abundance in ways that German planners found incomprehensible. Each Liberty ship required approximately 2,700 tons of steel. The program consumed over 7 million tons of steel for hull construction alone, plus millions more tons for engines, equipment, and fittings. This represented more steel than Germany's entire 1,943 military production across all categories. The United States Steel Corporation alone produced more steel in 1943 than Germany, Japan, and Italy combined. When Liberty ship production demanded additional steel, American mills simply increased output. There was no need to choose between building ships or building tanks or building aircraft. American industry could do all three simultaneously, while also producing refrigerators, automobiles, and consumer goods for domestic markets. German war planners had based their strategic calculations on assumptions of resource scarcity. In their experience, industrial production always involved trade-offs. Building more ships meant building fewer tanks. Allocating steel to one program meant denying it to another. The German economy operated under constant resource constraints, where every decision involved sacrifice. The American economy operated without such constraints. When the Liberty ship program needed 100,000 additional workers, unemployment provided them. When it needed millions of tons of steel, steel mills increased production. When it needed shipyard facilities, new yards were built in months. The concept of unlimited industrial capacity, where demand could simply be met by increasing supply, was alien to German planners, who had spent years managing scarcity. This abundance also meant that quality standards could be lower. German ships were built to last decades. Liberty ships were built to last through the war. If a Liberty ship survived 5 years, it had exceeded its design life. This acceptance of planned obsolescence allowed much faster construction. Why spend extra time welding seams to perfection when good enough welds would last the required 5 years? Why use premium materials when adequate materials met specifications? German engineers viewed this as shoddy construction. American engineers viewed it as pragmatic efficiency. Both were correct from their respective perspectives. But in wartime, pragmatic efficiency that produced adequate results quickly was infinitely more valuable than perfectionism that produced superior results slowly. The Liberty ship program's economic efficiency was also remarkable. Each vessel cost approximately $2 million to construct. Over 2,700 ships represented about $5.4 billion total investment. This sounds enormous until compared to military expenditures. The United States spent over $300 billion on World War II. The Liberty ship program represented less than 2% of total war spending, while providing the cargo capacity that enabled everything else. More tellingly, Liberty ships paid for themselves through service. Each ship could transport 10,000 tons of cargo per voyage. With an average of 20 to 30 voyages during wartime service, a single Liberty ship transported 200,000 to 300,000 tons of goods. The value of that cargo vastly exceeded the ship's construction cost. From a pure economic perspective, Liberty ships were profitable investments, even ignoring their military necessity. The strategic impact of Liberty ship production extended beyond the Atlantic. In the Pacific theater, Liberty ships supported island-hopping campaigns by transporting supplies, equipment, and troops across vast oceanic distances. The logistics of fighting Japan across the Pacific required massive cargo capacity. Liberty ships provided it. Every Marine landing, every Air Force base, every Army advance depended on supply lines maintained by these vessels. The liberation of Europe similarly depended on Liberty ship logistics. Operation Overlord, the D-Day invasion, required transporting millions of tons of supplies across the English Channel. Liberty ships carried much of that cargo from American ports to Britain. The subsequent drive across France consumed thousands of tons of supplies daily. Liberty ships ensured those supplies kept flowing. Without adequate shipping capacity, the Allied armies would have stalled for lack of food, ammunition, and fuel. Post-war analysis by the U.S. Strategic Bombing Survey concluded. The Liberty ship program represented the most important single industrial accomplishment of the American war effort. Without Liberty ships, Britain would have starved, the Soviet Union would have lacked critical supplies, and Allied offensives in both Europe and the Pacific would have been impossible. The program's success vindicated mass production techniques, demonstrated the value of accepting adequate quality at scale over perfect quality in limited quantity, and proved that American industrial capacity could meet any demand, regardless of magnitude. German post-war analysis reached similar conclusions from the perspective of strategic defeat. General Alfred Jodl, Chief of Wehrmacht Operations Staff, testified at Nuremberg. The Liberty ships defeated us as surely as any army. We sank thousands of tons of Allied shipping. They built it back faster than we could destroy it. We destroyed their ships with submarines. They destroyed our strategy with shipyards. It was not a fair competition. We were fighting with weapons. They were fighting with factories. And factories won. Admiral Karl Dönitz, in his memoirs written after the war, acknowledged, "If I had understood American industrial capacity accurately in 1942, I would have advised Hitler that the U-boat campaign could not achieve strategic victory. But German intelligence consistently reported that American shipbuilding claims were propaganda, that production numbers were exaggerated, that the Liberty ships were inferior vessels that would prove unseaworthy. All of these assessments were wrong. The ships were adequate, the numbers were accurate, and the production rate was sustainable. By the time we realized the truth, we had already lost the production war. And losing the production war meant eventually losing the entire war." This admission from Germany's submarine commander represented complete validation of American industrial strategy. Quality didn't matter when quantity reached overwhelming levels. Craftsmanship didn't matter when standardization enabled mass production. Traditional shipbuilding wisdom didn't matter when new methods proved more effective. The final irony of the Liberty ship program was its post-war legacy. Many of these vessels, built to last 5 years, served for decades. Some remained in commercial service into the 1,960 seconds and 1,970 seconds. Several still exist today as museum ships or memorial vessels. The supposedly inferior, quickly built, mass-produced Liberty ship outlasted most traditionally constructed vessels of its era. The SS John W. Brown, now a museum ship in Baltimore, still operates occasionally, conducting educational cruises. The SS Jeremiah O'Brien, moored in San Francisco, remains fully operational and participated in the 50th anniversary D-Day commemoration in 1994, crossing the Atlantic under its own power at age 50. These ships, dismissed by German engineers as propaganda or inadequate construction, proved more durable than anyone expected. Today, the Liberty ship stands as a monument to American industrial philosophy. Accept adequate quality, achieve massive scale, sustain production long-term, and let overwhelming quantity compensate for individual limitations. This approach applies beyond shipbuilding to almost every aspect of American military production in World War II. Tanks, aircraft, weapons, ammunition, vehicles, all produced in quantities that German planners initially dismissed as impossible, then feared, then ultimately acknowledged as the primary cause of their defeat. Friedrich Hartmann survived the war and worked in West German shipbuilding reconstruction. In a 1968 interview, he reflected on his reaction to those first Liberty ship reports. "I laughed at American claims in 1942 because they contradicted everything I knew about shipbuilding. And everything I knew was correct, within the context of traditional construction methods. What I failed to understand was that the Americans weren't bound by traditional methods. They invented new methods that made my knowledge obsolete. That's the lesson Germany failed to learn until too late. We assumed our enemies would fight the war using our rules, our methods, our assumptions. The Americans didn't. They rewrote the rules. They mass-produced where we crafted. They standardized where we customized. They employed factory workers, where we relied on master craftsmen. And their approach won not because it was better in any absolute sense, but because it was better suited to the specific requirements of industrial warfare. When I look at modern shipbuilding today, everyone uses American methods from World War II. Modular construction, prefabrication, welding, standardization, all standard practice now. The Liberty ship wasn't just a successful program, it was a revolution in maritime engineering that changed the industry permanently. And we laughed at it because we couldn't imagine that our traditional ways might not be the only ways, or even the best ways. That laughter cost us the war. This acknowledgement, from the engineer who dismissed Liberty ships as propaganda, provides the final validation. The ships German experts mocked as impossible were not only possible but represented the future of shipbuilding. The production rates German planners considered fabricated were not only real but sustainable for years. The American industrial capacity that seemed too large to be credible was actually even larger than initial reports indicated. When Friedrich Hartmann laughed at those intelligence reports in September 1942, he was laughing at his own strategic defeat. He just didn't know it yet. The ships he dismissed as propaganda would carry the supplies that enabled Allied victory. The production system he considered impossible would become industry standard, and the industrial philosophy he couldn't comprehend would prove that adequate quality produced in overwhelming quantity defeats superior quality produced in limited quantity every single time when wars extend beyond the aggressor's resource capacity. That's the lesson the Liberty ship taught, written across every ocean in the world, in the welded hulls of 2,000, 710 vessels built by American workers who learned shipbuilding in weeks and produced at rates professional shipbuilders considered impossible. Industrial capacity wins modern wars. Mass production defeats craftsmanship. Adequate quality at overwhelming scale defeats perfect quality at limited scale. The Germans learned this truth too late, one Liberty ship at a time, until the Atlantic, Pacific, and Mediterranean were filled with vessels that German engineers insisted couldn't exist, built by workers who German doctrine said lacked sufficient training, using methods that German tradition declared unacceptable. And those impossible ships carried the supplies that won the war.